Right, so we've got a few questions. We'll go through them, and then we'll call it a day, I think. Okay. So a bag contains 3 red. Oh, it looks familiar. 3 red, 2 blue, 5 green marbles. Okay. So let's just draw a bag. Okay. It's a maths lesson. It's not an art lesson. So 2 blue. What is it? 3 red. 1, 2, 3. And 5 green marbles. 1, 2, 3, 4, 5. What is the probability of selecting a blue marble? Okay, well, the probability of blue, maybe I should put it in blue, is going to be equal to the number of blue divided by the number of marbles. That's the sample set, is the number of marbles. So the number of blue is 2, and how many marbles are there in total? Well, 2 plus 3 plus 5 is 10. So it's 1 over 5, which is 0.2, which is 20%. If you wanted to put it like that, either of these, any of these are okay. Okay. You flip a coin 50 times and get 30 heads and 20 tails. Compare the experimental probability of getting heads with the theoretical probability. Okay, so the expected number of heads is the probability of getting heads times the number of trials. So I'm going to presume it's a fair coin. There's a 0.5 50-50 chance of getting heads times 50, so we would expect to have gotten 25. We actually got 30 out of 50, which is 0.6. So that's our kind of experimental probability that we got. So I mean, that's not completely out of left field. If anything more than 50 and you keep getting 0.6, you really want to have a look at that coin though. Okay, so I'm not quite sure what they're asking for. So the theoretical probability is 0.5. The experimental probability is 0.6. I think that's what they're looking for. Okay. All right. In a game, you win 12 times out of 40 trials. What is the relative frequency of winning? Well, the relative frequency of winning is the same thing as the probability, really. So the relative frequency, actually it's going to be lowercase f, is going to be the number of positive outcomes divided by the total number of possible outcomes. We're going to presume that each of these 40 trials is identical. So it's going to be 12 over 40. I think that's 0.3, isn't it? $12 divided by 40, I think it's 0.3. Is 0.3. 0.3, and they want it as a percentage. So 0.3 times 100 is, of course, 30%. Okay, a die is rolled. Okay, a die, I don't know. That must be true. A die is rolled and a coin is flipped. What is the probability of getting an even number and a tail? Okay, we'll construct a probability tree, and we'll say that we roll the die first and then flip the coin. So what's the probability? So here's where we start. So this is our die. So this is even. This is odd. How many evens are there? There's 3 out of 6. And there are 3 out of 6 odd ones. And we don't really need to worry about this now. What is the probability? And then get an even number and a tail. Okay. So this is going to be heads. It's going to be tails. This is going to be half. This is going to be half. So even and heads, remember we multiply down the branches. So we're going to multiply down the branches there. So the probability of even and heads is going to be 3 out of 6, which is half, times 1 over 2. So it's going to be 3 over 12, which is 1/4. I guess you could write that as decimal fraction, 0.25. Or as a percentage as 25%. Okay. A spinner. Here we go. A spinner has 3 equal sections, red, green, and blue. Let's actually draw it. Ugh, that's bad even by my standards. Let's rub that out. That's a terrible circle. Have another go. It's a little bit better. Red, green, and blue. And they are 3 equal sections. Okay. So this one is going to be blue. This one is going to be red. And this one is going to be green. And they have equal amounts. And then there is a spinner, which kind of spins around. Until it stops. So the probability of getting any of these is 1/3. And then it says a coin is then flipped. Draw a tree diagram, so I guess I'm in a probability tree, and find the probability of spinning green and flipping heads. Okay, so it says that the spinner is done first. Let's do the whole of the tree. So it's going to be red, green, and blue, and then heads, tails, heads, tails, heads, tails. So the probability of spinning green, so this is going to be 1/3. And then flipping heads, that's going to be 1/2. So the probability of green and heads is going to be 1/3 times 1/2. So it's going to be 1/6. And let's do it as a decimal and a percentage. So 1 divided by 6. It's this horrible number here. Times that by 100. 16.666666 recurring percent. So in that case, you would probably leave it as 1/6. All right. The number of goals scored by a team over 7 games. Yes, this is a football team. Is 2, 1, 3, 0, 2, 4, and 2. All right. Find the mean, median, and mode. Okay, so the mean average, remember, is everything added up. divided by the number of terms. So everything added up, divided by the number of trials. Trials would be games in this case. So that's going to be 2 plus 1 plus 3 plus 0. You don't need to worry about that, but I'm going to leave it in. Plus 2 plus 4 plus 2. So that's 3, 6, 8, 12, 14. And how many games are there? 1, 2, 3, 4, 5, 6, 7. Over 7, so 14 divided by 7 is 2. So the average number of goals is 2. Then they want the median. So the median, remember, we have to put them in order first. So it would be 0, 1, 2, 2, 2. 3 and 4, and then find the middle number. So bottom, top, bottom, top, bottom, top, median. So the median is 2, and then the mode, well, the mode is the most common one. It's pretty obvious it's going to be 2. It occurs 3 times. It's going to be 2. Explain why the events rolling a 2 and rolling a 5 on a 6-sided dice are mutually exclusive. Well, they're mutually exclusive means that both can't happen, and at a maximum only one of them can happen. Okay, so there's no way when you roll a dice one time you're going to get a 2 and a 5. So rolling 2 and 5 is impossible. Therefore, mutually exclusive. Hopefully you can read my scribbles. Next question. I think this is the last question. Okay. A survey of 100 students. A good thing to go is sort of pick out the numbers there. So that's going to be N. Showed the following results: math, science, English, PE. So obviously this isn't the school that I went to, because PE would probably be 70. What is the probability that a randomly chosen student prefers maths or science? So how many students did maths or science? It's going to be the number that did maths plus the number that did science, which is 30, plus 25, which is 55, divided by the number of students, which is 100. So that's 55 over 100, which is 55%, which I guess you could say that's 0.55. And it's some quick fire questions for you.